Hey YouTube. So in my last video I talked about how the half adder works. We talked about the truth table and the algebraic expressions and the circuit, and then we compressed the half adder into a smaller circuit. So in this video I want to talk about how we implement the half adder, and we want to talk about how it's used, what it's used for, and how to draw the circuit for them. And the best way I can describe this is that half adders would be good for incrementing a number. Like let's say I have a 4-bit number and I want to add the number 1 to it. Well, the half adder would be used to add the 1 and then propagate the carry over to the next sum, and then so on until all the addition is finished. And this is exactly what we're going to do in this video, is we're going to take a 4-bit number and we're going to increment it. And then once we get the solution to that, we are going to draw the half adder circuit. And we're going to do that a couple of times so you get the idea of it. Alright, so let's say that I have a 4-bit number. I'm going to make it up. Let's say I have a 4-bit number. It's going to be 0, 1, 1, 1. Alright, and then I want to add the number 1 to it. Alright, so we know how to do the addition. We know that 1 plus 1 is 1 with a carry, or with a sum of 0 and a carry of 1, sorry. And then we do the same thing here. We have 1 plus 1 gives us a 0 for the sum and a 1 for the carry. And same thing again. 1 plus 1 gives us a 0 for the sum, 1 for the carry, and 1 plus 0 gives us a 1 for the sum, and then a 0 for the carry, but we're not going to show that. Alright, so how does the half adder do this? Okay, so if I have a computer and I wanted to add a 0, 1, 1, 1, which is 7 plus 1, my output should be 8, right? But the computer needs to be able to do this. And we already know how the circuit works because we did that in my last video. Now we want to combine the circuits so that the computer is able to perform this operation. Alright, so let me pick some good colors here. Alright, let's do red. Alright, so each half adder represents one column of numbers. Each half adder represents one column of numbers. So one half adder is going to do the first column. The second half adder is going to do the second, that's a terrible line, is going to do the second column. And I'm going to do the half adders in different colors, so this is more visually pleasing and hopefully easier to understand. And we're going to do the third one in green, so our third half adder is going to take care of this third column. And then our fourth half adder is going to be this ugly yellow color, and it's going to take care of this last column right here. And you'll notice that it's only adding 2 bits. Remember, the half adder can only take 2 bits at a time. If there's 3 bits, like let's say I have a 1 right here, this wouldn't work. This would no longer work because we're adding 3 bits at a time. So we have to stick with the half adder rule and only add 2 bits at a time. Okay, so let's do the first half adder. So we're going to do the red column, okay? And we're going to draw it over here. Okay, so remember this is our little mini circuit, our little box. And we have 2 numbers for inputs. I use the arrows into the box to represent inputs. Well, it looks like we're adding 2 ones together through poorly drawn lines. And it's important to label this, so half adder. Alright, and we have our sum. Well, we know our sum is 0. And we carry a 1 to the next half adder. Alright, so this is representing this carry that I'm pointing at up here. Okay, so now let's go on to the next half adder. We're going to do that in blue. So let's draw that right here. Okay, this is a half adder. It's always important to label it so we know what we're looking at. Okay, well, we know that our carry is a 1, and we know that our other bit is a 1. So we're adding 2 ones together again. And we know that our output is going to be 0, because 1 plus 1 is 0 plus a 1 that's carried. And then we have a 1 that is carried into our next half adder. Alright, and we're doing this one in green. Alright, so now we're going to add 2 more bits. 2 more bits. Okay. Label this the half adder again. Okay, so it looks like we're adding 2 ones together once again, and our sum is a 0, and our carry once again is a 1. And we have to go back to this ugly yellow color. Save the worst for last, I guess. Okay. And we are adding 2 ones. Nope, sorry. We're adding a 1 and a 0 together. Well, 1 plus 0 is 1. And then we carry a 0. Well, if you'll notice, these numbers that I'm underlining at the bottom of the half adders, this is our sum. This is our sum, which is the same as this sum that I'm pointing at up here. So 7, this is 7 in decimal, right? And this is 1 in decimal. And we added that together to get 8. And which is equal to, oh, oops, what is that? Okay, 1, 0, 0, 0 in base 2. So this is the half adder circuit for 4 bits. So this is actually what's going on inside the computer when it wants to take a 4-bit number and add it together, or sorry, add it with, or excuse me, take a 4-bit number and increment it by 1. And it takes these numbers that I underlined in black, and then it takes it to the memory or to the next part of the operation or whatever it is being told to do. Alright, so let's do one more so we can get the hang of this. Let's do one more. Let me clear this. Okay, so let's take another 4-bit number. I'm going to make one up again. Let's do 1, 0, 1, 1. Okay. I'm going to add the number 1 again. Okay. So 1 plus 1 is 1 and carry a 0. 1 plus 1 again, 1, carry a 0. And 1 plus 0 is 1. And then we have a 1 here. Alright. So please excuse my terrible handwriting. I'm still trying to get used to this tablet. Alright, let's box in our columns so we know what we're dealing with here. So the red half adder is going to deal with that column, and the blue half adder is going to deal with this second column right here, and then the third half adder is going to deal with this third column right here, the green one, and then the fourth half adder is going to deal with the the fourth column. Okay, so now let's do the red half adders. Do the last column first, or first column, I should say. Okay, so this is our half adder. This is our poorly drawn half adder, and we have an input, it looks like, of 1, and a second input of 1, and we have a sum of 0 and a carry of 1. Alright, so now let's do the blue one. Okay, let's see here. This is our half adder, and we have a input of 2 1s. 1 is being carried in from the last half adder, remember. And then we have an output of 0 for the sum, and then an output of 1 from the carry. Alright, so now let's do green. Let's do green. So this is another half adder, and it's going to take an input of 1 and 0, and we know that 1 plus 0 is 1, and we carry a 0. Alright, last half adder, we have an input of 1 and 0, and we have an output of 1 and a carry of 0. And if you'll notice again, these numbers that I'm underlining in black are the same as this row that I'm pointing to up here. That's a terrible arrow. Let me redo that. There we go. And this is exactly what the computer does, because we know what's going on in the circuit within the half adder, right? Because we did that on the last video. So now we just tie 4 of them together, and then the computer is able to take any 4-bit number and increment 1, and then we get our output. It takes that number, like I said, and stores it in memory or performs another operation on it or what have you. It doesn't matter. Alright, so that is how we combine half adders, and it also explains what they're used for and how they operate in groups. So thank you for watching, and stay tuned for my next video.